All right, this next example is a calculator allowed question. And we're told that the function f, such that f of x is equal to e to the power of x minus 3, has got an inverse function f inverse. In part A, the question says to find the values of x where the graphs of f and f inverse intersect. Now, there's an old sort of trick that we've been using a few times, or we have used earlier in the year, to find the intersection between a function and its inverse. So let's try to visualize it, and it's not necessary, not asked to draw a picture here, but it can be helpful. If we're thinking about the graph of e to the power of x minus 3, well, that's just the graph of e to the x that's been translated to the right by 3. So it's going to look something roughly like this. And we also know that the inverse is a reflection in the line y equals x. So if I draw in at least a rough sketch of the line y equals x, that's the function f of x, we can kind of see or get the sense that the inverse, even if we roughly sketch the inverse would do something like this. It'd be a log graph. It comes up and it's going to be a reflection in the line y equals x. And so what we know is that this point of intersection here and this point of intersection here must also occur along the line y equals x. So the trick that we can use is, rather than trying to find the inverse function and then have to let the inverse equal the original, what we can actually just do is let the original function equal x and find the point of intersection between f of x and x, because that will be the same points of intersection that we would get with the inverse and the original function. So our little shortcut is to say, well, the values of x where the graphs intersect, for this we can just let f of x equal x, which essentially is just e to the power of x minus 3 equals x. We can solve that on the calculator. Now, there was an error in this question, I should have pointed out at the start, but this should say to 3 decimal places, which is a bit of shorthand there. So even though it wasn't given in the question, it should have been given in the question. This is to 3 decimal places. And the solution to this equation, or the solutions to this equation to 3 decimal places, are x equals 0.052 and x equals 4.505. So apologies for missing that in the question, but it should say corrected to 3 decimal places. Okay. Second part of the question says, hence determine the area enclosed between the graphs of f and f inverse. Again, you can use a little bit of a shortcut here. When we look back at the quick sketch that we drew, you might notice that, and excusing my bad picture, but if this is all a reflection, if both of these functions, f and the inverse, are a reflection of the line y equals x, then we've actually got some symmetry going on. This area that I'm going to shade here, I should have made the picture a bit bigger, but hopefully this is enough to see what's going on. This area here is just a mirror image of the area that's between the inverse and the line y equals x. So to get the sort of the full area, we can find the area between f of x and f inverse of x, but the other approach would just be to find the area between y equals x and f of x, and then double that area, because this area here will be equal to, we'll use a different color to try to distinguish it. The orange area will be equal to this green area, and so therefore, rather than having to work out the inverse function and use that in the calculation, excuse my dog barking, you can just use the area between y equals x and the function f of x. So, just going to push through, and hopefully he shuts up in a minute. The area will equal the integral from, and now our terminals are important here because these were the x values where the area starts and finishes. So the points of intersection from above become our terminals. So 0.052 is the lower terminal, 4.505 is the upper terminal. And if I'm finding just this area that I've colored in orange, well, the function that's on top is y equals x, the function that's on the bottom is f of x. Okay, so the area will equal what goes inside the integral is x minus f of x, which is e to the x minus 3 with respect to x. Okay, but remember, this is only giving us half of the area, and so to keep the working kind of consistent here, I'm going to say, well, that is actually all going to then be multiplied by 2. Okay, so we put this into our calculator carefully. I haven't got my calculator here, unfortunately, to put on the screen, so I had to just do it on the computer earlier. The result that we get when we put this into the calculator with the times by 2 at the end is 11.39, and again, I'm just remembering that I forgot to put this instruction in the question, 11.39 units squared if we go to 2 decimal places, which the question should have said. So apologies, a bit of a messy example, that one. Now, importantly, like a question like this is probably going to be worth a couple of marks, even if it is a calculator question. So it is important that you show this working step. Obviously, you're not required to go and evaluate that integral by hand, but you still need to show a working step if the question's worth 2 marks. So here we'd get 1 mark for a correct working step, 1 mark for a correct answer.